So when you're looking at functions, so we're taking a look at this cubic function right now. When you're looking at functions, there is what is called local maximum, local minimum, and then increasing and decreasing intervals. So that's what I want to go over right now. If I just draw a random function, that's a really bad one. I don't know. Nope. Okay. I draw this random function. What do you think I mean by local maximum? Very good. Why is it not just the overall maximum? Why do I not just say maximum? What's happening to this right-hand side? It's up and up forever. So technically, is there a maximum? Well, technically, it's infinity, right? It keeps on going on forever. Now, where would my local maximum be? Would it be this low point, do you think? Or this high point? Yeah, this is called a local maximum. It's not the true maximum, but it's in our, what we can see, it's our local high point, a local maximum. And what do you think about local minimum? Yeah, right here, this low point that we can see. All right, so now that we've covered local maximum and local minimum, where on this function do you think we're increasing? From the local minimum going up, yep. Right here. This is increasing. Going up forever. Yes, this one's kind of tricky to think about, right? Does this really look like it's increasing? No, the arrow's pointing downward, right? Upon first inspection, you would think this is decreasing. However, we always read a function left to right. So if I'm starting on the left, what is the lowest point it goes? Negative infinity. So I start at negative infinity, and as I'm reading left to right, where am I actually going? Upward. So that's why this is increasing. And then I get to the local maximum, and what happens? Oh, now I'm decreasing. So this is decreasing here. Ugh. This is increasing. Any questions about the general way to find local max, local min, increasing and decreasing? Okay, so now we're going to apply this to an actual problem. So like I said, everyone's going to need a calculator. Now on your test, you're going to receive two documents. One that is no calculator and the other that is with calculator. Luckily enough for you, this content is going to be on the calculator portion. So what you need to do first is take this function, f of x, and plug it into your y equals. So you go to y equals and you, oh, I'm so sorry. It would help if I didn't block it. You're going to plug in negative 3x raised to the third power plus 5x minus 6. And then you're going to graph it. Now looking at this, does it have a local minimum? Yeah. Does it have a local maximum? Yes, right? The local minimum is right here, and the local maximum is right here. Does anyone remember how to find the local? We'll start with, well, it asks for the maximum first. So how do we find the local maximum on the calculator? By the way, there is a way to do this without a calculator. However, that's much higher level math, so you will not be learning that yet. Anyone remember? Okay, so you press second, calc, which is the trace button. And then look, it says maximum minimum. So we're looking for our maximum first. So go to 4 and press enter. And then it says left bound. What do you think that means? Oh, Chris, I think I have your calculator. Well, I looked at him and I saw him and I remembered. Up there, over there, on top of my bookshelf. Okay, so left bound, what do you think that means? Yeah, get to the left side of your maximum. So anywhere to the left of this high point right there and press enter. And then right bound, get to the right of that maximum. And so I'm over here somewhere and then you press enter. And then it says guess. Now really it wants you to get right about on top of it, but it doesn't really matter. You can just press enter again and it'll give it to you. So our maximum is at 0.75 and negative 3.52. So it's at 0.75, negative 3 point, what did I say? 52? Good. So that's our local maximum. Now I'm going to do the exact same thing, but with minimum now. So you go to your graph, and you press second, trace, and then you go to minimum now. So number 3, and press enter. So now we're getting to the left of our minimum, our local minimum, anywhere on the left, and you press enter. And then it says right bound, so you get to the right of it, anywhere on the right, and you press enter. And then guess, you get about on top of it and press enter. So this time it's at negative 0.74, or again, negative 0.75 and negative 8.48. What did I say? Negative 8.48. No, you do not have to write this. If you want to keep track of it, you can. All right. So once you have your local maximum and local minimum, that's all that you actually have to compute on the calculator. The increasing and decreasing, all we have to do is really look at our local max and local min and figure out where we're increasing. So on this function, where are we increasing? Right. So we always read from left to right. We start off decreasing, and then what is this low point? What did we call that? Local minimum. Oh my God. Local minimum. We start at the local minimum, and when do we stop increasing? At the local maximum. Now, when we're trying to write our increasing interval, do you think I care about the x values or the y values? We care about the x. What x values make the entire function increasing? So we're looking at the local minimum first. That's our start point. The local minimum's x value is what? 0.75. So that's where we start increasing. Oh, sorry, negative. I was pointing at the maximum. We start at the minimum. So negative 0.75. And looking back at our function, when do we stop increasing? 0.75 at the x value of the maximum. Does this make sense? So we started increasing at negative 0.75 and we stopped increasing at 0.75. And we put brackets around it because, so this is what this function looks like, right? Looks like this. We started increasing here and we stopped here. At these actual points, at this literal point, am I increasing? No, this is a change of direction. So I'm not actually increasing at negative 0.75, so I put a parenthesis because I'm not increasing there. If this function had started at this point and increased like this, then I would put a bracket because I am increasing at that point. It's not a change of direction. Does that make sense? Okay, good. So, back to our function. Where am I decreasing? When do I start decreasing? On the, remember the x-axis, we're looking at the x values. So when do I start decreasing? Negative infinity. To where? When do I stop decreasing? At what x value? So I'm decreasing here. I started at negative, the x value of negative infinity, way over there, right? And I keep decreasing till where? Yes, the minimum. I stop decreasing at the local minimum, which has an x value of negative 0.75. Is that the only place that I am decreasing? No. Where else do I decrease? Yes. So I am decreasing, change of direction, increasing, and then I start decreasing again at my local maximum. So my local maximum x value is 0.75. And when do I stop decreasing? Positive infinity. Good. And because there are two intervals, you put the union symbol between them. Any questions? And also, how many real roots did this function have? 1. How many total roots does it have? So I have 1 real root on the x-axis, right? How many other roots does this have? Imaginary roots, really. 2 more imaginary roots right here. See how this, it goes down, but then it suddenly decides to go back up and then back down again, creating an almost upside down parabola there. There are 2 imaginary roots there. Also, what could have told you how many possible roots you end up with is this leading term's exponent, which is 3. So how many roots could you possibly have? 3, but there's only actually how many real ones? 1. Good. What the heck is going on? 1. How many real roots are there? 1. Now,